Hi, this is Miss Park. This video is the first of our discrete functions unit, and it's just going to set up some vocabulary for describing sequences. So we had a little introduction in class to sequence, and the first sequence we looked at was the Fibonacci sequence, and here it is written for you here on the top of this page. And what a sequence is a list of numbers. They are called terms, and they have an order, okay? And they're separated by commas, so you can see how they look here. And so you can look at the sequence and you can predict future terms. So if you recall with Fibonacci, each term is the sum of the two terms before it. But the first two terms have to be given because you can't look at terms before them. So you have to give a 1, you have to give a 1, and then after that, all the other terms are determined from the terms before that. Okay, so 2 is 1 plus 1, 3 is 1 plus 2, 5 is 2 plus 3, 8 is 3 plus 5, and so the next one's going to be 13, which is 5 plus 8, and then 8 plus 13 is 21, and then 13 plus 21 is 34. Okay, so we can continue that sequence because we know the formula for calculating any term if you know the terms before it. Okay, so in a sequence, each term has a term number n. So the term number is the position of the term in the sequence. So if you look at the terms in the sequence, we can number them. T1, that's term 1, T2, T3, T4, all the way up to Tn. And n is some number that we don't know, like it's anything, right? N can be any number. Important thing to know is that n can't be like 2.5. There's no such thing as term 2.5, right? They have to be what we call the natural numbers. So n is an element of the natural numbers. So I'm just going to write that over here. Natural numbers, and the natural numbers are the numbers that we count with. The ones, you know, you learned when you were a baby, you learned how to count 1, 2, 3, 4. So there's no 0, there's no negative numbers, there's no decimals, okay? It's just the numbers that we count with, natural numbers. So that's what n is. And since we don't know what n can go up to, it can be any natural number, we call Tn the general term. And so we're going to figure out formulas for Tn, which is if I know something about the sequence, then I can find a formula for term n, which means really any term. Okay, there's two ways of writing formulas. The first one's called explicit, and the second is called recursive. Okay, the recursive is a little bit easier to write. And I'll show you what I mean. So for example, let's take this sequence over here, 1, 3, 5, 7, 9. Okay, we can try to find a formula for calculating any term n. So for example, we know this is term 1, this is term 2, this is 3, 4, and term 5. Okay, and so what would be term 6? It would be 11. What's term 7? That's 13. What's term n? Okay, and so with term n, because we don't know what n is, we would have to find a formula that involves n to figure out that. But the recursive formula is actually a bit easier. So recursive formula says, just like with Fibonacci, if I know where to start, so if I know that I'm going to start at the first term is a 1, so T1 is 1, then how do I get the next term if I know the previous term? So I'm going to start with a 1, and here I can see that every term is the previous term plus 2. So if I know I can start at 1, then what I can say is, so then after 1, any term, so Tn, is going to be equal to the previous term. So look what I'm doing, Tn and Tn minus 1. Let me fix that so it looks better. Okay. Any term is equal to the previous term. So Tn is any term. Tn minus 1 is the term before that. So any term is equal to the term before that plus 2. And this will work when n is 2, when n is 3, when n is 4, when n is 5, when n is 10,000, right? It's always going to be the current term is equal to the previous term plus 2. So the only time that doesn't work is when n is 1. Because when n is 1, we don't have a previous term. That's just t1, and that's why we have to give it. So what we say is we say this is the formula. The formula is t1 is 1, and then any tn is tn minus 1 plus a 2, as long as, so and, n has to be greater than 1. Okay, because if n was 1, that second part of the formula doesn't work. So we're giving a formula for t1, and then we're giving a formula for all the other n's. Okay, and that is recursive formula. So let's talk for a moment about explicit formula. Okay, so have a look at this sequence and see if you can figure out some kind of pattern between the term number and the term. Okay, so pause the video for a moment and see if you can figure out, if we didn't look at previous terms, how do we get, think of it like a table of values, actually. Let's do it this way. Think of it as a table of values. Okay, and so our term numbers are here. And our terms are here, 1, 3, 5, 7, 9. Okay, like a table of values. So could you come up with an equation that relates x and y over here? And hopefully you're noticing this is actually linear, because you can see there's first differences are 2, they're the same. Okay, so see if you can figure out some kind of relationship between x and y. So pause the video here. Okay, so hopefully you've had a chance to think about it. It's not the easiest thing, but if you found the formula using this table of values, then hopefully you notice that Tn is equal to 2n minus 1. So T1 is 2 times 1 minus 1, which is 2, which is 1. T2 is 2 times 2 minus 1, which is 3, and so on. So how do you do that? Well, with the table of values, we can see the first differences are 2, so that's a slope of 2, right? Because it's a straight line. And if I go up and I add term 0, which doesn't really exist, but if I follow the pattern and go term 0, I would have a point. So if I put a term 0 here, then if I follow this pattern, I'm subtracting 2 every time, I would have a y value of -1. That would be my y-intercept. And so that is y equals mx plus b. And so I have y equals 2x minus 1. Okay, so that's just grade 9. So here you have your explicit formula. And another way to write this is using function notation, because we're in grade 11 now. We know function notation. So fn equals 2n minus 1. So the word recursive means it uses previous terms. Okay, and the word explicit means you just need to know n. You just, it's based on, I was going to write here, based on the term number. So with the explicit formula, if I said to you, okay, what is term 10,000, right? What is term 10,000? You would just have to take 10,000 and put it into the formula, and you would tell me that's 2 times 10,000 minus 1. But if I give you a recursive formula like this, and I said, what is term 10,000? Well, that would be a little difficult, because then you'd have to say, well, term 10,000 is term 9,999 plus 2. But then term 9,999 is going to be term 9,998 plus 2. And so you'd have to know all those other terms in order to figure that out. So even though the recursive formula was easier to write than the explicit formula is easier to use than the recursive formula. All right, so 2 kinds of formulas. So let's do another one. Example 2, recursive formula. Okay, so we're going to start with T1 is 2. And then how do you get each term from the previous one? So you double it. So if T1 is going to start at 2, so then any Tn is going to be equal to the previous term, so Tn minus 1, times 2. As long as n is greater than 1, because it won't work when n is greater than 1, because Tn minus 1 would be T0, which doesn't exist. Okay, take a moment and think about the explicit formula, some relationship between the term number 1, 2, 3, 4, 5, and the term. So pause the video here. Okay, hopefully you've noticed that it's just growing exponentially. So Tn is 2 to the exponent n. And if I write it in function notation, f of n is 2 to the exponent n. So again, if I told you what is term 100, then you could sub it in and go, oh, that's 2 to the 100. But if I asked you with the recursive formula, what's term 100, then you'd have to know term 900, you'd have to know term 99, and then you'd have to know term 98 and 97 and so on. Okay, let's do the next one. Question 3, recursive formula for this one here. So always with recursive formula, you have to give it where to start. And now you look at how is each term related to the term before that. Sorry, I have to tell it where to start. So T1 equals negative 10. And now how do we get from negative 10 to the next term? So it looks like we're multiplying by negative 2. So I'm just going to fix my negative. It looks like we're multiplying by negative 2 each time to get the other terms. So Tn is going to equal to negative 2 times Tn minus 1. But n has to be only when n is greater than 1, because when n is 1, it doesn't work. It's the first part. So a recursive formula, hopefully you're noticing, always has 2 parts. Where to start, and then how to get the term if you know the term before it. Okay? But the part of where to start is really important. You have to tell it where to start, because that will change your entire sequence if you start in a different place. Okay, explicit formula. You can pause the video here and try and think about it. Okay, there's probably more than one way to write the explicit formula for this, but here's one that works. So negative 10 times negative 2 to the n minus 1. That, I believe that gives you the correct terms. N minus 1. We can also write it in function notation. F of n equals negative 10 times negative 2 to the n minus 1. So when n is 1, negative 2 to the n minus 1 is negative 2 to the 0. So you get negative 10 to the 0, negative 10 times negative 2 to the 0, which is negative 10 times 1. And that's how you get that one there. And then when t is 2, you get negative 10 times negative 2. And yeah, I think that's going to work for all of them. Okay, so that wasn't so easy. And then let's go to our friend Fibonacci. And Fibonacci has 2 terms to start with. So notice there's 3 lines given here for the recursive formula. That's because the formula is that every term is the sum of the 2 terms before it, which means I don't have a formula for T1. I have to give it. I don't have a formula for T2. I have to give that one too. My formula only starts with T3. Okay, so Tn is equal to the 2 previous terms. So that would be Tn minus 2 plus Tn minus 1. Those are the 2 previous terms. As long as n is greater than 2, not 1, 2, right? Because when n is 1, we have to give the starting point. When n is 2, we have to give a starting point. And then after that, when n is greater than 2, so 3, 4, 5, and so on, then we can use the rest of the formula. So this formula has 3 parts. And notice I didn't put a line for explicit formula for this one. This requires some research. So the Fibonacci sequence, finding an explicit formula for it is actually a very difficult thing. So I will leave it to you if you're curious. You can go and research it, but we're not going to do it in our course. Okay, so thank you for watching. Now you understand the different types of formulas and a little bit of the terminology, and you're going to need all of this for the rest of the unit. Okay, thanks for watching. See you.